Hi there, folks. This is the Algebra 1 Unit 10 review, and as always, I am the amazing Mr. Jansen. So away we go. If I take a look at these the first couple are really just kind of asking me to briefly look at these and determine what's going to happen to the function. If you remember, the first function we ever graphed was y equals x squared, and that was the first parabola we'd ever seen. And then from there, every other parabola looked similar, except it was moved one way or the other, or stretched or shrunk based on the a value. And so the thing that we discussed here was that whenever we add or subtract inside with x, so if you break it down this way and say, okay, it's going to be x squared. Whenever you move this thing, whenever you change this guy, if you add or subtract in here from x, it's going to move it left and right. And that one always does the opposite of what we think. When we add, it moves us to the left. When we subtract, it moves us to the right. Same thing out here. When we add or subtract on the outside out here, it's going to move us up and down for the function. And that one does exactly what we would think. Adding moves us up and subtracting moves us down. So like when we look at these guys, the very first one I'm subtracting inside with x, so it's going to move me to the right that many units, so that's c. The next one I'm adding on the outside, so that's going to move me up that many units, which is a. The next one I'm adding on the inside, so that's going to move me to the left that many units, which is d. The next one I'm subtracting on the outside is going to move me down that many units. And then the last one, that one's not going to move left, right, or up or down at all. It's going to still be at 0, 0. But when you change the a value, remember, it changes the height of this thing. And since that's a 2, it's going to stretch this thing. It's going to double all those y values. Okay. The other way to think about this is if you think about each of these in kind of vertex form. This one's y equals x minus 3 squared plus 0. This one would be y equals x minus 0 squared plus 3. This one, just think about them in vertex form. And so when you think about them in vertex form like that, if I kind of write them that way, here just think about the vertex. The vertex is 3, 0. Here the vertex is 0, 3. Here the vertex is negative 3, 0. Here the vertex is 0, negative 3. And here the vertex is 0, 0. Really, that shows us these shifts, and the discussion we've had is the reason vertex form works the way it does because we're moving this thing up, down, left, or right. But now just look at the vertex compared to the original. The original had a vertex of 0, 0. So now it should be obvious based on the vertex that the first one, the vertex is moved to the right 3 units. The next one, it's moved up 3 units. The next one, it's moved to the left 3 units. And the fourth one, it's moved down 3 units. The last one hasn't changed, but we just need to understand what the a value does to this thing. So just real quickly looking at these things and kind of examining what that means for these guys. Okay. The next one it says is if a is greater than 0, in other words, if a is a positive value, then does the function open up or down? Well, if the a is positive, then it opens up. And then the next one, if a is less than 0, in other words, if a is negative, then the parabola is going to open down. And really, the thing, most students remember that a being positive opens up, a being negative opens down. The thing that we tend not to realize is that a greater than 0 means positive. A less than 0 means negative. That's just the mathematical way of saying it. Okay? The next one's just determine if the vertex is a maximum or minimum. Well, really, just think about the way this thing opens. So like the very first one here, I've got a negative a value, which means this parabola would open down. And the a is a 2, so it would be a kind of skinny downward opening parabola. Not that that really matters here. But if the parabola opens down, you see the vertex is right at the tippy top of this thing, which means the vertex is a maximum value because it's at the top. The next one, the a value is a positive 1/2, so this thing's going to open up. It's going to be a wide parabola that opens up. Well, either way, if the parabola opens up, the vertex is now at the very bottom of this thing, so that's a minimum. The next one, the a value is a positive 2, so it's going to open up and be a skinny parabola. since the vertex now is at the bottom, so when the parabola opens up, the vertex at the bottom, it's got to be a minimum. The next one, the a value is a negative, and it's a -1, so it's actually our standard shape. So standard shape opening down, but the a value being a negative makes this thing open down, which means the vertex is at the top, so it's a maximum. Okay, we're not looking for a whole lot of details here. We're not doing like super accurate graphing at this point. We're just saying in general, let's get an idea of what this thing should look like. And really, if you have these general ideas in mind and you understand, okay, this thing should be moved this way, it should open up, it should open down, it should have a maximum, it should have a minimum, it makes things really easy to do when you start looking at some of these other things. Okay, and it makes it easier to check the graph as well. All right. This one, it says match the equation with the number of solutions, also known as the x-intercepts. And so there's two ways to do this. We could actually just think about the graph of each of these. So like this one, I would start with like this guy. This one has a vertex of 0, 0, and it opens up, which means the graph kind of looks like this. And so when you think about that, the x-intercept, there's only one x-intercept of x equals 0. So right away that tells it that this is B, one solution. Okay, we could do the same thing with the other ones. We could find the vertex, like in this one. If you were to find the vertex of this one, the vertex you'd find is, let's see, down here somewhere, and this one would open up, and so immediately you can see that across the x-axis at two different places, so I would say it has two solutions. And then this last one, if you were to find the vertex of this thing, the vertex on this one would actually be up here somewhere, and this thing opens up, and so you can see that it doesn't cross the x-axis at all, and that's why it's no solution. Okay, so just quickly looking at the graph, think about the vertex in the direction of opening. That'll tell you how many solutions this thing has. Okay, the other option, though, if I were to start from scratch here, is to literally just find the solution. So I plug a 0 in for y, and I'm just going to solve. So if I take each of these off to the side, so here if I take that first one off to the side, I've got x squared minus x minus 6 equals 0. The first method I always try for solving is solving by factoring, so I build a bridge. That's a -6. Two numbers that multiply to -6 but add to a -1 or a -3 and a +2. So now I can go right to my shortcut for factoring this thing because I have a 1 out front. So it's x minus 3 times x plus 2. And now I can set each factor equal to 0. And I solve each. And so really, even before I write down my answers here, I can see that I have two answers. So that means there's two solutions here, which is letter C. Okay. The next one, again, I plug a 0 in here. So if I plug a 0 in for y, let me write it the other way. So I've got 1/2 x squared equals 0. Again, I could solve this one. I could use the square root to solve it, which we've done when we solved the Pythagorean theorem. So x squared equals 0. Or I can just kind of think of it in factored form. Again, solved by factoring, this is x times x, which is x equals 0. And then I go, oh, x equals 0 and x equals 0. So I get the same answer twice, which means I just get one answer, x equals 0. Okay, so I just have one solution here. So really I'm just solving it and seeing how many answers I get. And then the last one, this one we'd have to write as 5x squared plus 0x plus 10, since I'm missing that middle term, equals 0. And then from here I might try doing something like building a bridge. So maybe I'd build a bridge and say, all right, two numbers that multiply to a 50 but add to a 0. Well, that's impossible. I can't do that. So then I'd have to do like my quadratic formula for this thing. Okay, so I'm going to jump into my quadratic formula. I do the opposite of b plus or minus the square root of b squared minus 4 times a times c, all over 2a. And then it's just a matter of simplifying. That's a -0, well, which is just 0, I suppose. Plus or minus the square root of 0 minus what looks like 200, all over 10. So now I have 0 plus or minus the square root of negative 200 over 10. And this is where I can stop and say, oh, I can't have the square root of a negative. Square root of a negative is impossible for us at the moment. So then I would say, oh, this is no solution. Okay? And so by finding the actual answers, I can tell what kind of solutions there are. And really, when you think about that first one, the easiest thing to do is just to solve by factoring. Okay? When you look at the second one, the easiest thing to do is just think about the vertex and the direction of opening, kind of think about the graph. And then the last one, also I think the easiest thing to do is think about the vertex and the graph in order to come up with that. All right? So just keep in mind the solutions and x-intercepts are the same thing. You can use a combination of those two things to find out the answers to these guys. Okay? The next one says give the equation the axis of symmetry. We all know that the axis of symmetry is always x equals the x value from the vertex, so really I'm going to take the same approach that I would take to find the x value for the vertex. To find the x value for the vertex, I do the opposite of b over 2a. Remember, that gives me the x value for the vertex, and then I would plug it back in to get the y value for the vertex. In this case, I don't need the y value, so I just do opposite of b as a 12 over 2 times a, which is a negative 3. So now I have 12 over negative 6, which is a negative 2. And then from there, that's the x value for the vertex. Well, I don't even need the y value because the axis of symmetry is always x equals the x value from the vertex. So that's it. The next one, it says to put these in order from widest graph to narrowest graph. And remember, when you're looking at something like the a value here, really the bigger the a value is, the more vertically stretched this thing is going to be. Remember, the a value is what multiplies my height. So if I multiply the height by a really big number, this thing gets stretched vertically, which makes it look really skinnier. So the bigger the a value is, the skinnier it's going to be. The smaller the a value is, the wider the thing's going to be, because again, when I make the a value really small, I'm squishing this thing down, I'm making it shorter. And when I make it shorter, it naturally makes it wider. Okay? So the widest one is going to be the one with the smallest a value, which is the 1/4. The next widest is going to be the next smallest a value. And I just work my way up. Well, I guess I should put these as y equals, because I'm actually writing the whole equation, right? And then the last one is the one with the biggest a value. That's the skinniest. Okay? And so again, remember, that's how the a value affects this thing in terms of the shape. So again, these are all very kind of generic questions and just trying to look at, all right, what do we generally know about these functions really quickly without having to do a whole lot of work. Okay? The next one, looking at this graph, the vertex is the maximum or minimum point. So right here, the vertex is this guy right here, which is 1, 4, it looks like. And then it asks, is that vertex a maximum or minimum? Well, it's at the top, so it's a maximum. And then the next thing asks for the solutions, which again, really is just asking for the x-intercepts. And if we wrote them as solutions, we'd probably say x equals a negative 2 and x equals a positive 4. Okay, those are the x-intercepts. Or you can write them as ordered pairs. That would be fine as well. You just write it as negative 2, 0 and 4, 0. Okay, but solutions and x-intercepts are really the same thing. The domain, this is kind of an old school type of question asking about the domain, but when you go from left to right, the function goes to the left forever. It also goes to the right forever, which means all the x values are covered. So I would say the domain is x such that x is all real numbers. You can write all real numbers or use the symbol for all real numbers and then close it out. Okay, the range, when I look up and down, the thing goes down forever, but it doesn't quite go up forever. It stops right here at a y value of 4. Okay, it doesn't go any higher than that value of 4. So I have 4 and everything underneath it. So I would say the y values, y such that y is less than or equal to a 4. And so we're just applying something that we've already done in the past to these parabolas. Okay. Next one says give the coordinates of the vertex. Again, to find the vertex when it's in standard form like this, to find the x value, I do the opposite of b over 2a. So the opposite of b this time is a negative 32 over 2 times a, which is a 4. And then I just have to simplify. That's a negative 32 over an 8, which gives me a negative 4. So now again, that's the x value for the vertex. I have to plug that back in to get the y value. So I have to plug it back into this function. So I do 4 times a negative 4. That's an ugly looking 4. Let me try again. Times a negative 4 squared plus 32 times the negative 4 minus 25. Okay, and this either becomes a job for my calculator. If you use those parentheses and plug them in exactly the way they're written, you can just plug it right into the calculator. I'll simplify it by hand real quickly. So that's 4 times 16. That's going to be minus 128. And now if I continue, let me scroll down just a little bit to simplify. Here I get a 64 minus the 128, which is a negative 64 minus 25. And so I find out that my y value equals a negative 89. So that's my vertex, negative 4, negative 89. And that's it. Opposite of b over 2a gives me the x. Plug it back in to get the y. All right, that's vertex. These guys, it says to solve each. The first method you should always check for solving these guys is going to be factoring. And then from there, if factoring doesn't work, then we're going to go to the whole completing the square thing. Okay, so in this one, it's already factored. Remember your zero factor property. You need it equal to 0, then you factor, then you set each factor equal to 0. Since this one's already factored, I just set each factor equal to 0. X minus 6 equals 0, and then the 4x plus 1 equals 0. And I solve each. This first one, I've got to add that 6 to each side. So I end up with x equals 6 is one of my answers. The next one, I'm going to have to subtract the 1 from each side. And then divide by the 4. So the two answers I get here are an x equals 6 and x equals a negative 1/4. And that's it. Okay. Next one's a similar situation. It's already factored. It's already equal to 0. So now I just set each factor equal to 0. I do the 3/4 x equals 0. Here I do the 6 minus 2x equals 0. And I'm going to solve each. That first one, you could multiply each side by 4/3, multiply by the reciprocal. Or you can take it in 2 steps and say, hey, to undo that divided by 4, I'm going to multiply each side by 4. Okay? And that gives me a 3x equals 0. And then you could divide each side by 3. It's the same thing, just in 2 steps. And I think most students prefer to do it this way. If you want, though, you can absolutely multiply by each side by 4/3, and that'll take care of it for you as well. Okay? This other one, I got to subtract the 6 from each side. So I end up with a negative 2x equals a negative 6, and then I divide each side by that negative 2. So I find out that x equals a positive 3. And those are my two answers. That's it. Okay. The next one, the zero factor property only works if I have this thing set equal to 0. So I'm going to subtract that 7x from each side so that I get this thing set equal to 0. So now I've got x squared minus 7x equals 0. And I want to factor this thing. I can factor out the greatest common factor. That's an x. Now it's equal to 0. I've got it factored. I set each factor equal to 0. X equals 0. X minus 7 equals 0. And then I solve each of these. That first one's already solved. X equals 0. This one I'm just going to add that 7 to each side, so I get x equals a 7. And now those are my two answers. That's it. The next one, once again, I got to get set equal to 0 first, so I'm going to add that 8 to each side. And then I always try factoring first. Since this is a trinomial, 3 terms, I build a bridge. 2 numbers that multiply to a positive 8 but add to a negative 6 are a negative 4 and a negative 2. I get to use my shortcut on this one because the a value is a 1, so I can go right to the 2 factors, x minus 4 and an x minus 2. And I would, at the very least, if you're going to take some shortcuts on this, at least show this step, and then if you want to write your answers from there, that's fine. I'm going to show all the work, so x minus 4 equals 0, x minus 2 equals 0, and then I solve each. Here I add the 4. So I get x equals 4. Here I add the 2. So I get x equals 2. That's it. The next one, once again, I got to get it set equal to 0 first, so I'm going to subtract the 6 from each side. Let me scoot that off to the side here a little bit because I think I'm going to need a little extra room on this one. So now I have 3x squared plus 7x minus 6 equals 0. I always try factoring first, so I build a bridge. That's a negative 18. Two numbers that multiply to a negative 18 but add to a positive 7 are a positive 9 and a negative 2. I can't use my shortcut for factoring on this one because there's a 3 out front, so my a value is not a 1. So I'm going to just split up the middle term and factor by grouping. So 3x squared plus 9x minus 2x minus 6 equals 0. And now I factor by grouping. Group the first two, group the second two. Out of that first group I can factor out a 3x, leaves me with an x plus 3. Out of the second group I can factor out a negative 2, leaves me with an x plus 3. And now my two factors are the 3x minus 2 and the x plus 3. Okay, it's what I got on the outside with what I got on the inside. And now I set each factor equal to 0. 3x minus 2 equals 0. X plus 3 equals 0. And then I solve each. Here I add the 2. I end up with 3x equals 2. Then I'm going to divide by the 3. And I'm kind of running out of space here. Let me do the next one. Here I subtract the 3 from each side. And so hopefully you can see that my two answers from that first one, my screen's scooting around here a little bit. So the two answers I get, that first one I end up with a 2/3. And the next one, when I solved it, I end up with x equals a negative 3. Okay, and that's it. The next one, same kind of thing. The only thing here is I noticed that they're each divisible by 5 first. So I'm just going to go ahead and divide each of those by 5, or each side by 5. So I divide each side by 5, which with my distributive property here ends up giving me this. It gives me x squared minus 4 equals 0. And now hopefully I recognize x squared minus 4 as a difference of squares. So that factors into conjugates, x plus 2 and x minus 2. And now I can set each factor equal to 0. Look for those special cases. Remember, difference of squares is the one special case that we've done. If you see perfect squares in subtraction, factors into conjugates. And now I can solve each of these. So here I subtract the 2. I get x equals a negative 2. Here I add the 2. And that gives me x equals a positive 2. That's it. The next one, it's already set equal to 0. I just have to factor this thing. This one's a greatest common factor situation. I factor out a 3x. And these are the ones we tend to overlook. We get so used to the ones where we have to build a bridge. When you have two terms, that you should always look for special cases. You should always look for greatest common factor. Here, for greatest common factor, now I set each factor equal to 0. 3x equals 0, x minus 3 equals 0, and now I solve each. This first one I have to divide each side by 3. So I end up with x equals a 0. The next one I have to add the 3 to each side. So I end up with x equals 3. And that's it. This one, once again, I need this thing set equal to 0 first. Whoops. Having a little trouble. Keeps sending my screen flying. So I'm going to subtract that 3x from each side. Oh, let me section this guy off too, so it's out of the way. I'm going to scoot this guy off to the side again, so I've got x squared minus 3x plus 2 equals 0. Okay, and again, I got to make sure I write that in the proper order. Okay, I have to have the x squared, then the x, then the constant term. And now I build a bridge. Two numbers that multiply to a positive 2, but add to a negative 3 are a negative 2 and a negative 1. I get to use my shortcut on this one because there's an a value of 1, so I can factor it into x minus 2 and an x minus 1. And now I set each factor equal to 0. And apparently I didn't need quite as much room on this one as I thought. I probably didn't need to scoot that over. Now I solve each. I add the 2 to each side, and I get x equals a positive 2. Here I add the 1 to each side, and I get x equals a positive 1. That's it. The next one, once again, let's get everything on the same side. I need it equal to 0 first. So I've got x squared minus 16 equals 0. And now this is once again a difference of squares, factors into an x plus 4 and an x minus 4. And now I set each factor equal to 0. X plus 4 equals 0, x minus 4 equals 0. And now I've got to solve each of these. At first one, I'm going to go ahead and subtract the 4 from each side. So I end up with x equals a negative 4. The next one, I've got to add that 4 to each side. So I end up with x equals a positive 4. And that's it. Okay. The next one, it's already equal to 0. The first thing I would probably do is build a bridge. So here I go. I'm going to attempt it. Build a bridge. That's a negative 3. Two numbers that multiply to a negative 3 but add to a negative 6. There are no two numbers. It's impossible. That doesn't work, which means this thing can't be factored, which means then I go to my quadratic formula. Okay? So quadratic formula, opposite of b, plus or minus the square root of b squared minus 4 times a times c, all over 2a. And from here I just do a little bit of simplifying. So here I've got the 36, and then this guy gives me a plus 12 all over 2. I keep simplifying. That gives me plus or minus the square root of 48 over 2. And then from here, this is going to be a job for my calculator. Just be careful as you plug this in. Remember, it's two things. I got to plug in 6 plus the square root of 48 divided by 2. Then I'm also going to have to do 6 minus the square root of 48 divided by 2. Okay? And so I plug each of those into my calculator. Probably the easiest thing to do, you either have to put parentheses. Your calculator will typically automatically set parentheses around this guy. You would need parentheses around the whole numerator then if you're going to do that all in one shot. The other option is to type in that numerator. So like in the next one, 6 minus the square root of 48, hit the enter button, and then immediately hit divided by 2. And then you kind of take control of that order of operations. Either way, when you plug this in, the first one gives you a 6.46. The next one gives you a negative 0.46. And so those are my two answers. And that's it. Okay. The next guy, again, I want this thing set equal to 0 first, so I'm going to subtract that 6 from each side. Because whether you're doing factoring or the quadratic formula, either way, you need this thing set equal to 0 first. Sorry. Sending the screen flying again. Just trying to section this off a little bit. But either way, this thing's got to be set equal to 0 first, so I've got 3x minus 6 equals 0. And again, I would always try building a bridge. This one's not going to work, but I'm going to try it anyway. Two numbers that multiply to a negative 12 but add to a positive 3. Again, that's impossible. All right? But that's how I know it can't be factored. If I can't come up with those two values, now I move on to my quadratic formula. Opposite of b plus or minus the square root of b squared minus 4 times a times c. And now all over 2a. And I just start simplifying. Negative 3 plus or minus the square root of 9 plus 48 divided by 4. And now that's negative 3 plus or minus the square root of 57 divided by 4. And now it's a job for my calculator. I type in the negative 3 plus the square root of 57 divided by 4. And that gives me a 1.14. I type in the negative 3 minus the square root of 57 divided by 4, and it gives me a negative 2.64. That's it. The next one, the thing is already set equal to 0, so I can try building a bridge, and that's the first thing I always try. That gives me a negative 18. Two numbers that multiply to negative 18 but add to a negative 4. Not going to happen, so I go to my quadratic formula instead. Okay, factoring didn't work. So I move on to my quadratic formula. All right. Opposite of b plus or minus the square root of b squared minus 4ac. all over 2a. I simplify a little bit. That's 16 minus 72 all over 6. And I keep simplifying. That's 4 plus or minus the square root of negative 56 over 6. And right here, as soon as I see that square root of a negative, don't even bother plugging it into your calculator. It's going to give you an error because you can't do the square root of a negative. We're going to say it's no solution, or really no real solution here. Okay? This one, a ball is thrown into the air with an upward velocity of 64 feet per second. That's not super important other than the fact that it's giving us our units here. Okay, that 64 is already part of the equation, which I did for you. But it's showing us that the height is in feet and the time is in seconds. Okay, and that's important just for units in terms of this thing. All right, so it's given by the equation h is in feet and t is in seconds, and we're following the function h equals negative 16t squared plus 64t plus 10. And we can see the 64 built in. That negative 16 has to do with the acceleration of gravity, and the 10 has to do with our starting value. But either way, we don't need all that information, and that's stuff you'll do in physics. But here it just says how long does it take the ball to reach its maximum height, and that's a pretty key word there, that word maximum. Okay. If we're talking about a parabola, which this is the equation where parabola and asks for the maximum, it's asking for the vertex. And so to find the vertex of this thing, I do opposite of b over 2a. Opposite of b is a negative 64 over 2 times a, which is the negative 16. So that's negative 64 over a negative 32, which gives me a positive 2. Well, I don't even need to find the y value for the vertex just yet. This really just asks me for the x value of the vertex. How long will it take? That's my t value. So the answer is 2 seconds. That is an ugly looking e I got in there. Let me try again. Okay. Now it asks what is the ball's maximum height. So now I have to finish off this vertex. The x value of the vertex was a 2. Now really I need the y value of the vertex because the x value this time is t. That's the time. The y value is the height. So now from here, I just plug this thing in. So I do negative 16 times 2 squared plus 64 times 2 plus 10. And I'm just simplifying a little bit. So 4, that's 128. This gives me a negative 64 plus 128 plus 10. That's a 64 plus 10, which is a 74. So that's the y value for my vertex, but that's interpreted as the height, so it's 74 feet. Okay? So vertex is always interpreted something opposite of b over 2a, but if it asks for maximum, we know we're talking about a piece of the vertex. You just have to figure out which piece of the vertex. Okay? The next part of this thing says, when will the object hit the ground? And the thing we should recognize is that the ground is really a height of 0. So it's really just a way of saying, hey, plug a 0 in for h, so I'd have negative 16t squared plus 64t plus 10 equals a height of 0. I want to know when that's going to equal a height of 0. Well, this is one that I just have to solve the quadratic. And really, you could try building a bridge on this, but it's not going to work. I'm going to go right to the quadratic formula here. So it's opposite of b plus or minus the square root of b squared minus 4 times a times c. All over 2a. And now I just start simplifying. And really this one, I definitely need a calculator for. I was going to need it either way, but especially on this one, you know, most of us, I don't even know what 64 squared is off the top of my head, so I plug it into the calculator and it spits this out. And then plus 640 all over negative 32. I continue to simplify. Negative 64 plus or minus the square root of 4736 all over negative 32. And now from here, it's a job for my calculator. I plug each of those in just like I've always done. I get a negative 0.15. I get a 4.15. And this is talking about time, so this is in seconds. Well, we know right away that time can't be negative, so I'm just going to get rid of this negative answer. For the purposes of this question, the negative answer does not help me. I only want the positive answer. It's 4.15 seconds. That's it. Okay. The last two here, we're just graphing these things. So I'm coming up with the graph. I need to find the vertex and the axis of symmetry. At the very least, I can find more than that, and many of us will need to find more than that. So to find the vertex, I do opposite of b over 2a. Opposite of b is a 4 over 2 times a 1/2. 2 times 1/2 is a 1. So that gives me a 4. That's the x value for my vertex. And now to get the y value, got to plug it back in. And I'll just plug that into my calculator, and I plug it into the calculator, I get a -6. Okay? Axis of symmetry is always x equals the x value from the vertex. The fastest way then to graph this thing is I start with the vertex here. So the vertex is 4, -6, which is right here. And then the a value on this one is a 1/2, which means this thing opens up. And if you remember, our standard shape for this thing is over 1 up 1 from the vertex over 2 up 4, from the vertex over 3 up 9. It's that squaring pattern, over 1 up 1, over 2 up 4, over 3 up 9, over 4 up 16. But then we do half of all those. Instead of over 1 up 1, I go up a half. From the vertex, instead of over 2 up 4, I go up 2. From the vertex, instead of over 3 up 9, I go up 4.5. From the vertex, instead of over 4 up 16, I go up 8. From the vertex, instead of over 5 up 25, I go up 12.5. Okay, that's the pattern that I kind of look for here. And then my axis of symmetry, I don't necessarily have to graph the axis of symmetry on this thing. I can, if I do graph it, it's right here. It's just this dotted line that goes through the vertex. And really that graph just helps me double my points, so I can start reflecting each of these points using the axis of symmetry. Okay? If you're not going to use the a value, remember the option then is you have to go to an xy chart. So I come off to the side and I do an xy chart, and I just say, oh, I'm going to use that 4 as kind of my starting value, and then I'll do something like 5, 6, 7, 8, and I start plugging values in. Okay? And when I start plugging those values in, it's just going to spit out, like I already know 4 is a -6. I plugged that in once. But if I use my calculator to plug the 5 in, I'm going to get a -5.5. If I plug the 6 in, I'm going to get a -4. If I plug the 7 in, I'm going to get a -1.5. If I plug the 8 in, I'm going to get a 2. Okay? And I could keep going. If I plug a 9 in, if I extend this a little bit more, I'm going to get a 6.5. Okay? And so, again, I just start plugging these things in and then go from there. All right? Now I can graph this thing. I've got plenty of information here. I just draw the best curve I can through those values. I missed a little bit when I went to graph this thing. There we go. Okay? Next one, same kind of thing. I'm going to come off to this up here and find the vertex. So the vertex, once again, is opposite of b over 2a. That gives me, let's see, -6 over 2 times a -1. -6 over a -2, which gives me a +3. That's my x value. I then plug that back in. And be careful, this is like a -1 x squared. And I like to treat it as a -1 and always use parentheses to plug things in. You'll make less errors. And you plug that in, you get a 6. Okay? Axis of symmetry is x equals the x value from the vertex. So then down here, I just start plotting this thing. Say, okay, vertex is 3, 6. So I plot that guy. The a value this time is a -1. So this thing opens down and has the standard shape. Over 1, down 1. Over 2, down 4, over 3, down 9, over 4, down 16, which brings me all the way down to the bottom. Okay, and then I can reflect each of those using my axis of symmetry. Okay, the other thing I have here is, things like the x or the y intercepts. I could plug some of those things in. Really like this one, the y-intercept is a 2. Here the y-intercept is a -3. And you can see that that's confirmed on my graph. All right. And I just draw the best curve I can. All right, and once again, if you're not sure, you do an XY chart. You just start your XY chart at a value of 3 and then choose like 4, 5, 6, 7, and start plugging those values in. It should give you this nice curve. Okay? Hope this was helpful and good luck on your test.